Continue a session over here, and I would like to introduce Edwin Robbins from Denodo, right? And it's a pretty interesting, I don't know if you guys have looked at the website and all that. It's a data virtualization fabric. It's an amazing story. They have grown quite a bit, around close to 400 customers and more than $300 million of revenue. Anyway, so Edwin is a senior sales engineer out of Chicago office. And actually, before joining this company, he was working at Oracle for 19 years. So
That's right.
The speaker before us worked for 20 years. So he just started over here, so they knew each other. Anyway, so he's basically what he's focusing is on. He's going to talk about the Oracle data warehousing solution as well, the Oracle ETL and BI hosted solution. That's what it's written over here, which is wrong.
Yeah.
But this is what is wrong.
Yeah.
So anyway, so basically it's going to talk about the big data fabric at scale, real-time analysis, and by the way, it's going to be interactive sessions. If you want to ask questions, you can ask while he's presenting. Thank you.
So I guess before I get started, how many people in here are familiar with data virtualization? So not too many. Okay. So as I'm going along, if you want to ask questions, please ask questions. It's a it's a story that we're gonna. It's a use case story I'm going to share. So hopefully it gives you some tangible ideas. So so I'll just start out with the problem statement from our customer and how we kind of help them solve it. So it's a heavy equipment manufacturer. For those of you that are familiar with Caterpillar, they're out of Illinois. They make very heavy, big machines for heavy duty use in industry. And they were facing a sort of interesting competitive challenge. So these machines cost millions of dollars. They're very, very big. They're very expensive, and they're meant to last a very long time. So they started facing competition from some new startup competitors that were not focused on creating more reliable or longer lasting machines. These competitors were focused on creating machines that only lasted for the lifespan of a given project. So rather than a construction company buying this machinery with the intent that it would last 25, 30, 40 years, the intent was they would simply buy these less expensive machines on a per project basis, and the expectation would be that they wouldn't have to maintain them long term. So, so Caterpillar was faced with kind of a dilemma, was how do they deal with this competition? Should they lower their price and hurt margins in order to compete on price? Or should they find another way to help maintain their high price and differentiate themselves in different ways? Okay? And where Denodo helped with this was by tying together all of their underlying data that was part of their IoT strategy. Okay? So the way Caterpillar dealt with this was these machines all have lots and lots of sensors on them, right? And so what they decided to do was they leveraged a product called OSI Pi that basically gathered all that sensor data and consistently streamed it to a Hadoop cluster. So they were gathering all the sensor data for the individual machines, but just having the sensor data wasn't enough to turn that into valuable information. So what they leveraged Denodo for was they leveraged our data virtualization layer to connect up to the sensor data, which was stored in Hadoop, but also to connect up to their parts inventory, their maintenance database, and their dealer databases, okay? And this gave them the solution in a couple of different dimensions. One was, now they were able to offer proactive maintenance information to their customers. So to the customers that were buying this more expensive equipment, they were able to say, not only is this going to last you longer, but we can guarantee that you'll have more uptime because we'll be able to notify you before these machines break down that you need to execute certain maintenance tasks. And so that increased the customer's uptime. By offering the service, the ancillary benefits were that now they also saved money on warranties. So all of these machines come with warranties, and now because they were breaking down less often, they also now had a higher profit margin because they didn't have to execute the warranty information. So the data virtualization layer that they put in for Denodo was servicing up their internal analysts who were looking at this information and making suggestions to the customers on what type of maintenance schedule they should maintain. And it was also serving up a dealer and a customer dashboard. So the Denodo layer is acting as this sort of aggregation engine for servicing this data in real time to the customers. So why did they go with Denodo as opposed to like a standard ETL tool? Well, the primary reason was timeliness. Okay, so if you're pulling data off of the sensors of the individual machines, a lot of times if you're waiting 24 or 36 hours for that to get processed through an ETL flow before it's available, it's too late. So the idea here is to capture problems before they actually exist. So if the machine breaks down in the middle of doing something, that's problematic. If you're able to tell it the day before, when it's in the shop, that it may potentially break down, but if you service it now, it won't, then that was actually a significant benefit. So, that being said, for those of you that still don't understand what data virtualization is, let me kind of peel back a little bit and let's explain exactly what we're doing. So, the first thing is, one of the biggest challenges that people deal with in the big data space is not just the volume of data and the types of data, it's the types or how that data is stored. So one of the biggest challenges is people having a hard time tying together data sets where one of them may be a NoSQL, one of them may be a Hadoop, one of them may be a web service, right? They all provide data, individual data points to the business, but tying them together in a common format is a big challenge. And that's what one of the things that Denodo does very well. We don't care what format your data is in, we can abstract it, present a semantic layer that allows you to access it, and then Denodo will figure out how to go and get the data. So this is from the Forrester research on what big data fabric should encapsulate. And this actually matches up fairly well to the capabilities that Denodo brings to the table. So you basically have all your different data sources down here, whether they're Hadoop or Spark or what have you, or standard relational databases. And the key capabilities that Forrester is saying a data fabric needs to have is the ability to transform data, integrate it, cleanse it, ability to do data modeling, to prep it, and then the ability also to leverage in-memory caches and in-memory data stores. And along the left-hand side are some of the ancillary capabilities that Denodo provides. So one of the nice things is any data element you access in Denodo, it has a full lineage tree. We can do data quality, search. We provide metadata for all the data that's in Denodo. And so the paradigm that we kind of present with Denodo is that rather than having people need to understand how to tie together data that's in Hadoop and all your different data sources, is allow Denodo to connect to those data sources and just have everybody get at the data through Denodo. So you have a single entry point for your data, and your end users don't need to know where it's coming from. Denodo will simply go and find it, or get it in the most efficient way possible. Excuse me. So this is kind of the top-down a diagram that we typically use to kind of show where Denodo sits. So as I said, it doesn't matter what your data sources are, Denodo can access them. And what we typically do is we would connect up to a physical data source, and we don't move any data. Okay, so that's one of the key things about data virtualization, is that it's not like an ETL engine or service bus or something like that. We're moving physical data. What we're going to do is connect up to your physical data sources. We're going to extract the metadata, so the names of your tables, your columns, statistics about that data, all that good information is stored in your source system. And we're going to store that metadata in the Denodo repository, which will be act as your single repository for all of your data elements. Then you have your data consumers that are going to connect to Denodo. And those consumers could connect via JDBC, via ODBC, and just issue SQL. They could connect via RESTful web services, via SOAP web services. So we have a number of ways that we can expose the information that is stored in that Denodo middle tier. And again, we're not going to store any data. So the way it works is, at runtime, let's say you have a BI tool. The BI tool, like Tableau or something like that, will make a JDBC connection to the Denodo layer. And when it issues a query, let's say it's issuing, it wants information on customer, right? And so let's say we have customer information that is stored in a database, in a bunch of flat files, in a SaaS application, okay? Well, when that Tableau request says, give me all the customer information, Denodo is going to go down and execute individual queries against those 3 different data sources and then present the result set up to the end user. So the end user tool only needs to issue a simple SQL statement, and Denodo is going to turn that into the individual statements for those individual sources. Okay? So this is a little bit more of a detailed picture of all the things that you would do in Denodo. And really, the entire development end-to-end flow can kind of be summarized in these 3 boxes. Okay? So you're going to connect up to a data source and import that metadata into the Denodo middle tier. You're going to do some transforming, some preparing of it. You may improve the quality of it, so you may do some lookups that turn the column values into a different column value or something like that. And you're basically going to do your enterprise modeling on the metadata only, and then you're going to expose that enterprise metadata model to your consumers. They're going to ask for the data, and Denodo's going to figure out how to go get it. Okay? So some of the other use cases that we've come across, the IoT integration is a very popular one these days. So I think the typical methodology has been, well, Hadoop is cheap storage. We can store all of our data there. Let's just start by putting all of our data, or the data that was maybe not worth putting in a database, we're going to dump that into Cloudera or Workworks or something like that. There's lots of SaaS applications out there like Salesforce and Workday and things like that. You've still got lots of on-premise applications as well as relational databases. And excuse me, the Denodo virtualization layer can tie all those together and just present that common model to the end user, so they don't need to know any of the underlying details. Another one of the common use cases is the data warehouse offload. So this is actually a very straightforward one and very similar to what the Oracle guys are talking about. So maybe you have a fact table with your sales data in your data warehouse that is 2 years old or less. And on your Hadoop cluster, you have all your sales data from more than 2 years ago. Okay? What you do is you connect these sources up in Denodo, and now your end users would simply see one logical table for sales. And if you issued a query that needed data from less than 2 years, Denodo is going to direct it here. If you issue a query that wants data that's older than 2 years old, Denodo is going to direct it there. So we kind of do data partitioning depending on where the physical source is. Okay? So normally I don't get this far in a presentation before somebody asks me how it performs. So typically that's like the biggest challenge that people have with data virtualization or data federation, is that they're very concerned about the performance. So I wanted to jump into one of our performance optimizations to give you an idea of how we approach the challenge of ensuring that virtualized environments can perform comparable to physical environments. So, so this is a simple query that we get from the TPC benchmarks, and this is from the decision support version of the benchmarks. And in this case, what we're basically doing is a simple join of a sales table in Netezza and a customer table that's in Oracle. Okay? The sales table has 290 million rows, and the customer table has 2 million rows. So if you were to issue that statement against a standard 2-source system in a BI tool, where we're basically saying I want to aggregate sales by customer ID, the way it's typically going to execute it is it's going to bring all this data into memory and then all this data into memory and execute the join. So there's a number of BI tools that will allow you to connect up to multiple sources, and this is how they execute it, right? So if you had 2 sources in Tableau and you issued this query, it's going to pull all the data into there and do your join and then do your aggregation. What we're going to do in Denodo, though, is we're going to make some inferences. So because we see that we're ultimately asked, the end result that we're asking for is an aggregation, And because we know that we're joining customer ID from Netezza to customer ID in Oracle, what Denodo is going to do is rewrite that query so that rather than moving the 290 million rows into here to do the join, it's going to pre-aggregate the data in Netezza. So now we're not going to move 290 million rows, we're only moving 2 million rows from Netezza into memory. And then we join it to the 2 million rows from Oracle, and you can see the result. So we didn't do any caching, we didn't rewrite the query, we didn't add any structures like any indexes or anything like that, and we were able to cut the query time down by an order of magnitude of about 12 or 13x, okay? And so this is what's called a aggregation pushdown, and we have about 4 or 5 of these types of optimizations that the Denodo optimizer will execute on the fly depending on the statistics of the underlying sources. So any questions on that?
I have one question.
Sure.
So let's say I go to the group, okay? I want the sales record based on the customer.
Okay, so you want all the
and
detail?
with some customer detail, okay?
Mm-hmm.
So then we need to bring the 290 million there, right?
Sure, but that's your result set. So what we're saying is, if your ultimate result set only needs to be 4 million rows, then don't move all that data over the wire. So so take the Denodo out of this. If you're saying that, and let's say you put this 2 million, the customer table in Netezza, right? Well, what are you really saving? You still have to move 290 million rows over the wire. That's the most expensive operation in this whole thing.
But and at that time, joining will be happen on the database server. And here it is on the Denodo, right? Denodo, on memory, right?
Oh, I'm sorry, what was that?
So in this case, so 290 million the sales row and the customer, it will
Right.
be joined in the
In Denodo, yeah.
Denodo. So and if we bring those two tables into Netezza, it will join happen on the Netezza, it will use the database power, right?
Sure.
So here.
Now remember, I said this is only one of our optimizations.
Okay.
All right, that doesn't mean that we don't have other ways of doing that.
Okay.
So so to your answer there, what we would do in that situation is we would copy this 2 million row into Netezza and do the join
Okay,
and then
okay,
return.
yeah.
That's what we would do. So this isn't meant to solve all the world's problems. It was just that one. Anything else? No? Okay. So some of the benefits of using data virtualization is the data fabric. So you greatly simplify your access to data. That's probably the biggest one, is rather than requiring your end users to know the characteristics of the data and know where to go find it at all times, you're basically providing a single place that they can go and get it. We also have ways to, basically describe the data that is in the Denodo repository. So again, we don't store data in our repository, we only store the metadata, but we do have ways to expose some of the content that's in there. So for example, you can build a Lucene or an Elasticsearch index on top of your Hadoop data and expose that through Denodo. So if you want to do a search for a particular customer, rather than scanning through 10 years of sales data, you can simply hit the Elasticsearch index. So we have a lot of capabilities to kind of give you the data exploration of what's actually available in your data catalog, okay? Extending traditional data warehouses. This is a very common use case. So building a data warehouse is a very labor-intensive task. It often takes years to do it. By the time it's built, the business has not stopped bringing new technologies on board. They haven't stopped bringing new data on board. So you often have situations where data elements that people want to query on are not part of the data warehouse. So rather than redoing the ETL, you can simply add a virtual dimension onto a data warehouse and just make that part of your query capabilities. The extension of data warehouse are capitalizing on memory computing. We just touched on that a little bit. We also, in the coming version of Denodo 7, are planning to have a in-memory grid for doing the types of very complex joins that you're talking about. So there are going to be situations where you've got to join two very big data sets. So your options today are either live with the pain or pre-join those in a cache. So we're going to add an in-memory capability for doing that. And also, you're now taking advantage of all of your underlying systems. So you have a distributed querying processing capability, and so now we're taking advantage of all those underlying systems instead of forcing all that data into a single place. And here are just some of the time savings and cost savings versus your traditional approaches. Probably the big ones are the ETL and data warehousing. So, you know, the typical timelines of 6 to 12 months, we a lot of times see those cut down to 2 to 3 months. So the data integration cost reductions are also quite big, and we also see it used quite often in sort of call centers and portals. So those are often applications that are pulling data from multiple places and need to kind of present a consolidated view, and so Denodo is very, very good at doing that. And so here's the latest on the big data fabric vendors. So this is from Forrester. You can see that we've made some nice progress there. And they actually have some very nice quotes about us. And I tend to actually agree with this. So I think one of our biggest strengths is delivering a unified and centralized fabric where people can just go get all the data. And it doesn't matter what the underlying data technology is. And lastly, I just have our splash screen for you. Our biggest customers are probably, well, we had Logitech present at another session just before us. Autodesk is a big one. Intel is probably our biggest one by far. There's about 700 Intel developers who are using Denodo today. So, any questions? Yep.
Yeah, when it comes to, like, for instance, with the use case that you had with Caterpillar, where was the data actually being stored?
Well, the internal ERP system was stored on Oracle, and the sensor data was all being stored on Hadoop. I'm not sure what distribution, but it was going to Hadoop. So we were basically combining data from Oracle data stores and Hadoop for the most part, with some other small pieces, but those were the biggest